Welcome to the Deep Dive, your shortcut to being truly well-informed without feeling overwhelmed. In a world just awash with information, our mission is, well, to cut through the noise, take a stack of sources, and extract the most important nuggets of knowledge and insight.
And hopefully add just enough humor and surprising facts to keep you hooked.
Exactly. Today, we're diving deep into something pretty fascinating. A series of practice questions and explanations from an actual artificial intelligence audit exam.
Yeah, think of it as a behind-the-scenes look, a peek under the hood at how AI systems are assessed for performance, ethics, reliability, all the important stuff.
That's right. What's really compelling here, I think, is that even though these are framed as audit questions, they really lay bare the critical foundational principles for anyone looking to understand how AI truly operates.
How it's governed, and crucially, where its potential pitfalls lie. We'll go through each question, the answer, and maybe most importantly, unpack the detailed justifications.
Connecting the dots, hopefully, to the broader implications of AI in practice. Okay, let's unpack this then. Our goal for you in this deep dive is to not just grasp the right answer for these questions.
No, not just rote learning.
Right, but to understand the why behind it. We want to equip you with insights you can actually apply and discuss.
So you'll gain a robust understanding of key AI concepts, one question at a time.
Let's jump in. First up, we're asking a pretty foundational question about how AI gets smarter, how it learns. Which of the following best enabled artificial intelligence models to continue to improve how they learn from training data? That includes recognizing patterns and predicting outcomes.
Okay.
Your options were A, statistical methods, B, data volume, C, hyperparameters, or D, computational power.
Okay, and the correct answer here is C, hyperparameter.
Hyperparameters.
These are those crucial settings established before an AI model even begins its training process. They really speak to the fine-tuning aspect of AI.
So wait, if they're set before training starts, how do they help with continuous improvement? That seems a bit counterintuitive.
That's a great point. Think of them like the detailed recipe for a really sophisticated dish.
Okay.
You've got the ingredients, that's your data. But the recipe specifies the exact oven temperature, the precise mixing time, maybe even the specific type of flour, right? These settings aren't learned from the ingredients.
They're set beforehand.
Exactly. They fundamentally shape how the model processes and responds to its input data throughout the entire training process. We're talking about things like the learning rate, how big a step the model takes when it updates its knowledge,
Right.
or the number of layers in a neural network, which defines its complexity. These aren't learned, they're chosen by the developer.
I see.
And critically, adjusting and optimizing these parameters, maybe between training runs or through techniques like cross-validation, that is the key to enhancing the model's skills. It allows for iterative refinement of the learning process itself.
So you tweak the recipe to get a better outcome next time.
Precisely, enabling continuous qualitative improvement in how the model learns and generalizes. It's about precision, not just raw ingredients.
That paints a really clear picture. So why aren't the other options the best enabler for this kind of ongoing improvement? They all seem pretty important for AI.
Oh, absolutely vital, just in different ways. Let's take A, statistical methods. They are the backbone, the mathematical grammar of machine learning algorithms.
The foundation.
Right. But they remain relatively constant within a given model type. They don't dynamically adapt to improve learning based on new training data in the same way you tune hyperparameters. They're the principles, not the tuning knobs.
Got it. What about B, data volume? More data is always better, right?
Well, yes and no. More data is usually very helpful, necessary even. But simply throwing more ingredients at a badly configured model, one with poor hyperparameter settings, won't necessarily make it continuously improve its learning capability. It might learn more, but not necessarily learn better. The hyperparameters govern how it learns from that data.
And computational power,
Like-
option D.
That gives you the muscle, the speed to process large data sets, run complex models faster. It enables learning, especially on big problems.
But it doesn't make the learning smarter.
Exactly. It doesn't directly contribute to refining the quality of the learning or the predictive abilities during training. It's about capacity and speed, facilitating the process, but not inherently improving the model's learning skill like optimizing hyperparameters does.
Okay, so the real insight here is that AI growth isn't just about more data or faster processors. It's about precisely tuning how it learns, making those hyperparameters the key drivers of continuous improvement.
You nailed it.
All right, let's shift gears. Moving into a crucial area that's, well, on everyone's mind, ethics. How can organizations best ensure that their AI solutions align with ethical principles and societal values?
A big one.
Yeah. Choices were A. Follow commonly adopted industry standards. B. Perform proactive evaluations of ethical impacts. C. Schedule regular audits of AI system outcomes. Or D. Ensure transparency of AI models.
And the best answer here, the most proactive one, is B, performing proactive evaluations of ethical impacts.
Foresight, you said earlier.
Exactly. Foresight is incredibly valuable here.
But this idea of proactive evaluation seems really forward-thinking. Can you give us a more tangible example? What does that look like in practice, beyond just a definition? How do you stop it from just being another checklist?
That's a really important question because it needs to be more than just box ticking.
Yeah.
It truly goes beyond just reacting after something goes wrong.
Right.
Proactive ethical impact assessments, sometimes called fundamental rights impact assessments or FRAAs, are designed to systematically identify potential concerns. Concerns about the use of the AI, its broader impact on people, on society, before it's widely deployed.
Before it's out in the wild.
Precisely. So let's take that loan application AI example. A proactive assessment wouldn't just look at accuracy. It would dig into, is there potential for bias against certain demographic groups based on the data or the algorithm?
Okay.
How fair is the decision-making process? What are the privacy implications of collecting and using this data? How might deploying this affect loan officers' jobs or even broader societal trust in financial institutions?
It's a whole ecosystem view.
Exactly. It's like doing safety and environmental impact studies before building a factory. The insights you gain are then used to shape the design. You embed these ethical considerations as fundamental requirements right alongside performance goals.
So it's part of the design spec, not an afterthought.
That's the key to making it actionable. It's about anticipating challenges and designing solutions, or even deciding not to proceed early in the development lifecycle.
That makes sense. And why are the other options, which seem like good ideas, not as effective for ensuring this alignment from the start?
Well, take A, industry standards. They're helpful, provide a baseline, definitely. But AI ethics are incredibly context-specific. A standard might not cover the unique nuances of your specific application or its societal impact.
Too generic sometimes.
Could be. Then C, regular audits of outcomes. Hugely important for ongoing monitoring, checking for bias drift, ensuring performance. But audits are inherently reactive.
They tell you what already happened.
Exactly. They spot problems after deployment. Proactive assessment aimed to prevent those problems in the first place. And D, transparency. Vital, no question. We need to understand how models work.
The black box problem.
Right. But transparency alone doesn't guarantee ethical outcomes. You can have a perfectly transparent model that was trained on biased data and transparently makes biased decisions.
Ah, I see. Transparency shows the mechanism.
But proactive evaluation ensures the mechanism is ethically sound from its inception.
Got it. So the really profound takeaway here is that ethical AI isn't something you bolt on later. It has to be built in from the very beginning through proactive thinking and design.
That's the ideal, yes.
Okay, we've covered how AI learns and the ethics around it. Now let's pivot to, well, maybe the most foundational piece, the data itself.
The fuel for the engine.
Right. Our next question gets into auditing this. Which of the following would be the main consideration of an IS auditor reviewing an enterprise's data management processes for AI solutions? Options are A, process for aggregating data from multiple sources, B, duration needed to transfer data, C, protection measures used on data from different sources, or D, cost analysis of data integration.
The correct answer, the main focus for the auditor in this context, should be C, protection measures used on data from different sources.
Protection measures.
This highlights a critical and sometimes overlooked risk in AI data pipelines.
So if I'm hearing you right, it's not just about getting all the data together, but making sure the security rules, the privacy rules, they travel with the data wherever it goes inside the AI system, like a passport for the data's protections.
Precisely. That's a great analogy. The core issue pops up when you aggregate data from lots of different places.
Yeah.
Maybe from marketing, sales, operations.
Different silos.
Exactly. Each source might have its own specific privacy policies, its own compliance requirements like GDPR or IPAY, its own security controls. When you pull all this data together, maybe into a big data lake for AI training, there's a real risk that those original protections, the consent obtained, the access controls, the security settings applied at the source, don't get adequately transferred or enforced in the new environment.
They get lost in translation, basically.
or just dropped. So the IS auditor's main job here is to verify that robust protection measures, think encryption, strong access controls, data masking for sensitive fields, adherence to regulations are consistently carried over with the data and are effectively applied in the new AI data store.
Ensuring compliance doesn't break down when data moves.
Right. It's about maintaining that security and privacy lineage throughout the data's lifecycle within the AI ecosystem, preventing that dilution of protection.
Okay. And why aren't the other options the primary concern for the auditor here?
Well, the process for aggregating data is definitely important. The auditor needs to understand it. But the main consideration isn't the how of aggregation, but the result are the protections maintained. Process is the means, protection is the end goal for the auditor.
Gotcha.
B, the speed of data transfer is mostly an operational efficiency concern. Important for performance, maybe, but not the auditor's core focus on risk and control.
Okay.
And D, cost analysis. That's a business management consideration, not typically the primary focus of an IS audit, which is about assurance over controls, risk, security, and compliance.
So the key takeaway, data security for AI means continuous protection, ensuring controls follow the data faithfully from source to solution.
Exactly right.
All right, next up, let's tackle a very real-world challenge. Data changes, right? So when modifications are made to the data sources feeding an AI system, what's essential to include in the change management plan to maintain the system's performance and reliability?
This happens all the time.
Yeah, options. A, manage data drift and standardize preprocessing steps. B, retrain the AI model immediately. C, implement access controls on new data. Or D, update the AI system software.
The best answer here is A, manage data drift and the standardization of preprocessing steps. This is all about staying agile when your data environment is constantly shifting.
Okay, data drift. That sounds kind of like the AI model needs glasses that automatically adjust focus as the world changes. Can you unpack that a bit more?
That's actually a really good analogy. Data drift refers to those shifts, sometimes subtle, sometimes pretty drastic, in the characteristics of the incoming data compared to the data the AI was originally trained on.
Okay.
Imagine an AI predicting customer churn trained on data from last year.
Wow.
But this year, maybe customer demographics have shifted, or economic conditions change, or your company launched a new product line that affects behavior.
The world changed.
Right. The patterns the AI learned might not hold true anymore. If the incoming data starts looking fundamentally different, the model's predictions will become less accurate, less reliable. That's data drift.
And it degrades performance.
Exactly. Detecting and managing this drift is essential for a long-term AI reliability. And crucially, standardizing those pre-processing steps is key. That means applying the exact same data cleaning, transformation, scaling, and feature engineering steps to the new incoming data as you did to the original training data.
Consistency is key.
Absolutely vital. This ensures that even if the raw source data changes slightly, the data actually fed to the model remains consistent with its operational expectations. It helps maintain performance without having to immediately jump to costly retraining for every little shift.
It's about keeping the input stable for the model.
Exactly. Proactive management of drift and consistent pre-processing.
So why aren't the other options the best approach for managing these specific data source modifications?
Well, B, retraining the model is often necessary eventually, especially if drift is significant. But it's a big effort, time-consuming, resource-intensive. It's usually a response to drift, not the first line of proactive management for ongoing changes.
Reactive, not proactive.
Right. C, implementing access controls. That's about security, who can input data.
Yeah.
It doesn't address the characteristics or consistency of the data itself for the AI model's needs.
Different problem.
And D, routine software updates, important for the underlying platform, the AI framework's health, fixing bugs, security patches. But it doesn't directly address changes in the data patterns the model relies on.
So the core idea, keeping AI reliable means actively managing how data changes over time, using consistent pre-processing and watching for that drift.
That's the essence of it.
Okay, our next question tackles a really critical ethical concern, bias. Which of the following types of bias would explain an AI solution showing signs of gender discrimination in its decision-making? Options: A, systemic, B, statistical, C, human, or D, overfitting.
The correct answer here is A, systemic bias. This really points to deeper, embedded issues.
So is it like the AI becomes a mirror reflecting the biases that are already baked into our systems or our historical data? What does that mean, systemic bias in AI?
That's a very accurate way to put it. Systemic bias isn't usually about a single programmer's prejudice, though that can happen. It often results from in-grade procedures, societal structures, or very commonly from inherent biases present in the historical training data itself.
The data reflects a biased reality.
Exactly. And the AI learns from that data.
Hmm.
So if you train a hiring AI on historical data where, say, men were overwhelmingly hired for engineering roles and women for administrative roles reflecting past societal biases,
Yeah.
the AI will learn that pattern. It won't question why that pattern exists. It will simply optimize to replicate the outcomes it observed in the data. It learns to associate gender with job suitability based on that flawed historical record.
So it perpetuates the past biases.
Precisely. It leads to undue favors or disadvantages for particular social categories, like gender in this example. Recognizing this is crucial. Proactive steps to mitigate systemic bias, like carefully curating data, using fairness-aware algorithms, rigorous testing, are absolutely essential.
It's acknowledging the AI is built on potentially flawed foundations.
Right. It's often a mirror. And if the underlying systems or data reflect historical inequities, the AI can amplify them unless we specifically design it not to.
And how do the other forms of bias differ from systemic?
Good question. B, statistical bias often comes from unrepresentative sample data. Like if a facial recognition system is trained mostly on faces of one ethnicity, it might perform poorly on others. That's a sampling issue. Systemic bias can exist even within a statistically representative sample if the underlying social reality captured in that sample is biased.
Ah, subtle distinction.
That is. C, human bias refers more to the subjective judgments of individuals involved in the AI lifecycle, maybe labeling data incorrectly based on their own biases or setting unfair objectives. Human bias can contribute to systemic bias, but systemic bias describes the broader ingrained pattern of unfairness.
Okay.
And D, overfitting, we touched on this earlier. It's a technical problem where the model learns the training data, including noise, too well and fails to generalize. It affects accuracy, not directly social fairness or discrimination in the way systemic bias does.
So the profound takeaway is that AI doesn't just operate in a vacuum. It often reflects and can even amplify the systemic biases present in our society and data, making proactive ethical design absolutely critical.
Couldn't have said it better myself.
All right, next, let's get into risk management again. How do you effectively weave AI risk assessment into the bigger picture of an enterprise's overall risk strategy? Which of these best incorporates it?
Integrating it properly is key.
Options. A, focus just on the financial ROI of AI. B, include specific characteristics of AI tech in existing processes. C, just maintain an updated risk register for AI. Or D, standardize AI risk assessments across departments.
The best approach here is B, include specific characteristics of AI technologies in existing processes. It's really about integration, not treating AI risk in a silo.
Okay, so we can't just sort of slap AI into our old risk management buckets and call it a day. Why is integrating characteristics the key?
Exactly right. You can't just treat it as more IT. AI brings unique, novel risks to the table. Things we've touched on. Model opacity or the black box problem, the potential for data drift to degrade performance unexpectedly, ethical biases leading to discrimination, and entirely new attack vectors like adversarial attacks that specifically target machine learning vulnerabilities.
Things traditional IT risk frameworks might miss.
They very likely would or wouldn't address them adequately. So the best practice is to consciously adapt your existing risk management methodologies. This means adding specific steps, controls, and considerations tailored to AI. For example, incorporating assessments for model explainability, building in regular checks for data and concept drift, establishing protocols for bias detection and mitigation, defining security testing specifically for AI vulnerabilities.
You're evolving the existing framework.
Precisely. You evolve your framework to be fit for the AI era. By integrating these AI-specific characteristics into your established processes, you ensure these risks aren't overlooked or managed separately, potentially inconsistently. It gives you a holistic, comprehensive view of the enterprise's risk landscape, including AI.
That makes sense. So what about the other options? They sound like parts of a good strategy.
They are parts, but not the best integration strategy. A, focusing only on ROI, that's a business case justification, not a risk management methodology.
Yeah.
Important, but different.
Right.
C, maintaining an updated risk register is absolutely essential. You need to document risks. But just updating a list doesn't explain how you're identifying, assessing, and managing those unique AI risks within your overall strategy. It's the record, not the integration method.
Got it.
And D, standardizing assessments across departments promotes consistency, which is good. But it doesn't address the core issue of how to adapt the assessment methodology itself to properly capture and evaluate AI's specific risk profile. It's about uniform application, maybe, but not the necessary adaptation of the method.
Okay, so the key insight. Effective AI risk management isn't about creating a separate AI risk silo, but about evolving your existing enterprise risk frameworks to specifically understand and address AI's unique characteristics and vulnerabilities.
Exactly. Integration is key.
All right, moving into section 3. Performance, resilience, and compliance. Question 7 is about evaluating performance. Which of the following is most crucial when evaluating an AI framework's performance as it generalizes to new, unseen information?
Generalization, that's the real test.
Options. A. Augmenting training data. B. Increasing architecture complexity. C. Reducing the training dataset size. Or D. Using validation data to fine-tune hyperparameters.
The correct answer, and this is really fundamental, is D, using validation data to fine-tune hyperparameters.
Okay, validation data. How does that work in practice? How does it help ensure the AI works in the real world?
Think of it like this. You train your AI model on its textbook. That's the training data. It might memorize everything perfectly.
Ace the practice problems in the book?
Exactly. But to see if it truly understands the concepts and can apply them to new problems it hasn't seen before, you give it a quiz or a test. That quiz is your validation data.
Data it wasn't trained on.
Right. A separate data set held back from training, specifically designed to evaluate the model's performance on new, previously unseen information. It acts as a critical bridge between training and real-world deployment.
Okay.
By testing on this validation set, you see how well your model generalizes how accurately it performs on data that reflects what it will actually encounter in production. And crucially, you use the performance on this validation set to fine-tune those hyperparameters we talked about earlier.
Optimizing for generalization.
Precisely. You adjust the learning rate, the model complexity, etc., based on how well it performs on the validation set, not the training set. This helps prevent overfitting, where the model just memorizes the training data, noise and all.
So it avoids deploying a model that looks great in training but fails in practice.
That's the goal. Without proper validation, you're flying blind into deployment.
Makes sense. So why aren't the other options as crucial specifically for evaluating generalization?
Well, A, augmenting training data, techniques like adding noise or rotating images, helps make the training more robust, which can improve generalization indirectly. But it's not the primary tool for evaluating how well it generalizes.
It's part of training, not testing generalization.
Right. B, increasing architecture complexity can actually hurt generalization if you're not careful. It makes overfitting more likely the model gets too specialized to the training data.
Counterproductive.
Often, yes. And C, reducing the training data set size usually leads to underfitting. The model doesn't learn enough, so it can't generalize well either.
Also counterproductive.
Correct. So B and C can actively hinder generalization. Validation data is the direct way you measure and tune for it.
Okay, key insight. AI models prove their real-world value by generalizing, not just memorizing, and validation data is the essential tool for measuring and optimizing that ability.
Couldn't agree more.
Our next question touches on a growing concern, the environment. Which of the following can help address concerns about the environmental impact of using generative AI?
Very topical issue.
Choices. A. Increase model complexity. B. Optimize algorithmic efficiency. C. Leverage existing infrastructure. Or D. Minimize the number of training data sets.
The best answer here, in a really active area of research, is B. Optimize algorithmic efficiency.
Algorithmic efficiency. I keep hearing about the huge energy footprint of these big AI models. Is it fair to say it's not just about using renewable energy, but actually making the AI itself, well, smarter and less resource hungry?
It's exactly it. The energy and resource demands of large AI models, especially these massive generative models that are constantly creating text, images, code, it's substantial.
The servers running them 24/7.
Right. They demand huge amounts of electricity and, critically, also significant water resources for cooling the data centers. This is where algorithmic efficiency becomes absolutely paramount.
How does that help?
By developing and deploying more efficient algorithms, researchers and engineers can significantly reduce the number of computational operations the calculations needed to produce a high-quality output.
Fewer calculations means less work for the processors.
Exactly. Less work means less energy consumed, less heat generated, less cooling needed. We're seeing work on things like model compression, using smaller, more lightweight models, developing more efficient training techniques, smarter ways to do inference.
Getting the same result with less effort.
Precisely. More bang for your buck computationally. This directly translates to reduced energy consumption and a smaller environmental footprint for every piece of content generated or task performed by the AI. It's vital for making AI sustainable as it scales.
Makes sense. And the other options, do they play any role?
Well, A, increasing model complexity generally does the opposite. More complex models usually require more computing power, more energy, so that's counterproductive from an environmental standpoint.
Okay.
C, leveraging existing infrastructure might save costs up front, but if that infrastructure is older, less energy efficient legacy hardware, you could be locking yourself into higher ongoing energy use compared to adopting newer, optimized systems.
Right.
And D, minimizing the number of training data sets mostly affects the initial training phase. Training consumes a lot of energy, yes, but for many generative AI models, the ongoing usage, the inference stage where millions of users are generating content, often represents a much larger cumulative environmental impact over the model's lifetime. And that's where algorithmic efficiency during inference really matters.
So the key insight, making AI sustainable isn't just about greener energy sources, but fundamentally about improving the algorithmic efficiency to reduce the energy and resource demands, especially during ongoing use.
That's a huge focus right now.
Okay, next up, security again, but focusing on active attacks. What method most effectively enhances an organization's ability to identify runtime and through-use attacks on AI systems?
Attacks that happen while the AI is live and running.
Options. A. Regular audits of access controls. B. Using static code analysis tools. C. Enhancing AI observability. Or D. Restricting AI interactions to internal networks.
The most effective method here is C, enhancing AI observability. This is absolutely critical for real-time defense against AI-specific threats.
AI observability, how does that translate into practice? Is it like having a super detailed, real-time dashboard monitoring everything the AI is doing, thinking, and interacting with?
That's a great way to visualize it. AI observability goes beyond standard IT monitoring. It enables an enterprise to recognize and respond to complex attacks that happen during runtime, while the AI is actively processing live data and also during through-use stages.
Through use, what does that mean?
It refers to attacks that manifest through interacting with the AI system itself. Think about someone subtly feeding the AI malicious data over time to poison its training, if it learns continuously, or crafting specific inputs designed to fool the model or cause it to reveal sensitive information. These are adversarial attacks.
Attacks targeting the AI's logic, not just the network.
Exactly. Traditional security tools might miss these. AI observability relies on integrated telemetry gathering detailed data about the AI's internal state, its performance metrics like prediction confidence, the characteristics of its inputs and outputs, how it's interacting with users and other systems.
A constant stream of data about the AI's behavior.
Right, that detailed real-time dashboard you mentioned. It doesn't just show performance, it immediately flags anomalies, unexpected outputs, suspicious input patterns, potential malicious activity. This allows for proactive defense and rapid incident response, catching attacks as they happen rather than cleaning up afterward.
That sounds powerful. And the other options, while generally good security practices, fall short for these specific kinds of AI attacks.
They do for these specific attack types. A, auditing access controls is fundamental prevention keeping unauthorized people out. But it doesn't catch attacks from authorized users or subtle input manipulations.
Okay.
B, static code analysis scans the AI's code for vulnerabilities before deployment. Very useful, but it doesn't track dynamic threats that emerge during live operation based on data or interaction.
Pre-flight check, not in-flight monitoring.
Good analogy. And D, restricting interactions to internal networks reduces the external attack surface, sure, but it does nothing against insider threats or attacks that exploit vulnerabilities during legitimate internal use. It lacks the necessary detection capability for these nuanced AI threats.
So the key insight. True AI security requires more than perimeter defense. It demands deep, continuous observability into the AI's live behavior to detect unique, evolving threats targeting the model itself.
You've got it.
Okay, our 10th question brings us to compliance, especially for critical systems. What aspect of documentation related to ongoing compliance should an IS auditor verify when assessing an organization's high-risk AI system?
High-risk AI, the stakes are higher here.
Choices. A. Initial risk evaluation records. B. Guidelines for user approval and data privacy. C. System development and implementation plans. Or D. Procedures for continuous operation surveillance and critical incident reporting.
The correct answer, focusing on that ongoing aspect for high-risk systems, is D, procedures for continuous operation surveillance and critical incident reporting. Continuous vigilance is key.
It sounds like for these critical AI systems, compliance isn't a one-time check during setup. It needs to be a living, breathing process, right? What does that mean in terms of documentation?
That's exactly right. For high-risk AI, like medical diagnosis AI, autonomous vehicle control systems, critical infrastructure management, maybe high-stakes financial fraud detection, you can't just audit it once and assume it stays compliant.
The system evolves, the data evolves.
Precisely. So the auditor must verify that the organization has well-defined, documented procedures for continuously monitoring the system's performance, its outputs, its adherence to ethical guidelines, its data usage, and importantly, for promptly identifying, reporting, escalating, and resolving any critical incidents or deviations from expected behavior.
What kind of deviations?
Could be anything: a sudden drop in accuracy, detection of unexpected bias, a security anomaly, outputs that violate safety parameters. The documentation needs to detail how this surveillance happens: indivisible, automated monitoring, human review points, what metrics are tracked, who is responsible, the thresholds for triggering an alert, and the exact process for handling critical incidents.
A clear playbook for when things go wrong or even look like they might.
Exactly. This proactive, continuous oversight ensures emerging risks are caught and addressed quickly, keeping the AI solution consistently in compliance with operational standards, regulations, and ethical commitments throughout its entire lifecycle.
Okay, so the other documentation options, while important, serve different purposes and aren't about that crucial ongoing compliance piece.
Correct. A, initial risk evaluation and inventory records are vital baseline documents from the setup phase. Essential context, but they don't cover the day-to-day monitoring of the live system.
Snapshot, not a movie.
Good way to put it. B, guidelines for user approval and data privacy are crucial for ethical data handling input, but don't directly address the ongoing surveillance of the output and operational behavior of the high-risk system.
Okay.
And C, system requirements and development plans tell you how it was built. Foundational knowledge, yes, but they don't describe the processes for monitoring and managing it after deployment to ensure it stays compliant and safe in production.
So the key insight for high-stakes AI compliance isn't a destination. It's a continuous journey requiring documented procedures for vigilant oversight and rapid response throughout the system's operational life.
Well said.
All right, Section 4, Specialized Skills, Testing, and Privacy. Question 11 dives into the skills auditors themselves need. What type of expertise is necessary for an auditor using judgmental sampling during AI audits to pick the right data samples for evaluating bias and reviewing training data?
Judgmental sampling relies heavily on the auditor's expertise.
Options: A, deep knowledge in the specific field of AI application. B, familiarity with general automated audit tools. C, understanding of AI regulations. Or D, proficiency in statistics and data sets.
The most necessary expertise here is A, deep knowledge in the specific field of AI application. It's about having the context to see potential biases.
So it's not enough for the auditor to just understand AI principles or audit techniques in general. They need to understand the domain, healthcare, finance, whatever that the AI is working in.
Absolutely critical, especially for judgmental sampling aimed at finding bias. To effectively evaluate bias outcomes and review training data, the auditor needs both AI competence and a deep, nuanced understanding of the specific field.
Can you give an example?
Sure. Auditing an AI for medical diagnosis. You need to understand AI models, yes, but also clinical data, medical terminology, patient demographics, known health disparities, potential biases within historical healthcare data or practices.
Okay.
Auditing an AI for loan applications. You need AI knowledge, plus understanding of finance, credit scoring models, relevant regulations like fair lending laws, socioeconomic factors that might correlate with protected characteristics and lead to discriminatory outcomes if not handled carefully.
You need to know where the potential traps are hidden in that specific context.
Exactly. This deep, domain-specific AI knowledge lets the auditor make informed choices when selecting samples. They can look at the data or the model's behavior and identify sensitive attributes, historical patterns of discrimination, subtle correlations, or proxies for protected characteristics that might embed bias. Without this context, biases can easily be missed. The auditor might not even know what to look for or where the highest risks lie in that specific application.
Like trying to find a specific error in a complex machine without understanding how the machine is supposed to work?
A very good analogy.
So why aren't the other skills sufficient on their own for this specific task of finding bias via judgmental sampling?
Well, B, familiarity with automated tools helps with efficiency, maybe analyzing large data sets. But the tools don't have the domain expertise to make the judgments about which samples are most likely to reveal bias.
Tools don't replace judgment.
Right. C, understanding regulations is crucial. It tells you what constitutes illegal or unethical bias, but it doesn't give you the technical or domain knowledge to actually find that bias hidden in the data or the model's logic for a specific application.
Knowing the rules versus knowing how to investigate.
Exactly. And D, proficiency in statistics and datasets is very helpful for analyzing the samples once selected. But again, without the domain knowledge, the auditor might struggle to select the right samples in the first place, or to interpret the statistical findings in the context of real-world fairness and potential harms.
So the key insight: truly effective AI bias auditing requires a powerful combination understanding the AI, understanding the audit methods, and deeply understanding the specific real-world domain where the AI operates.
That combination is essential for meaningful bias detection.
Okay, next, let's talk about how we can really understand the data an AI uses. How can a comparison testing method be used to assess different aspects of an AI model's dataset?
Comparison testing, a way to probe the data's influence.
Choices. A. Use fixed algorithms for clarity. B. Deploy automated code analysis. C. Employ techniques to identify weaknesses generally. Or D. Modify data attributes to assess their impact on outcomes.
The correct answer here is D, by modifying data attributes to assess their impact on outcomes. This lets you pinpoint how specific data features influence the model.
Okay, modifying data attributes. So you're sort of doing controlled experiments on the data set itself. How does that help you understand your AI's data?
That's exactly what it is, running experiments. Comparison testing, in this context, lets you systematically evaluate how specific characteristics or attributes within your dataset influence the AI model's performance or predictions.
How does it work?
Essentially, you take your dataset, or a representative sample of it, and you make controlled changes to certain attributes. For example, you might change demographic information like gender or ethnicity on some records while holding others constant, or tweak input values like income levels, or modify environmental variables if it's relevant.
You change one thing at a time.
Ideally, yes, or controlled combinations. Then you feed this modified data through the AI model and observe how its predictions or outputs shift compared to the original data.
And see what changed.
Exactly. This allows you to pinpoint which aspects of your data are driving particular outcomes. You can identify sensitivities like, does changing this one feature drastically alter the prediction? You can potentially uncover unintended biases. Does the model behave differently for different demographic groups, even when other factors are similar? Or find vulnerabilities. It's a powerful way to dissect that relationship between specific data inputs and the AI's outputs.
Really getting under the hood of the data model interaction. So why aren't the other options the right fit for this specific purpose of comparison testing on the dataset?
A, using fixed algorithms might help understand the algorithm's logic, but it's unrelated to the process of modifying data attributes to test the dataset's impact.
Okay.
B, automated code analysis tools look at the AI model's code checking for bugs, vulnerabilities, quality issues. They don't test the dataset itself through this kind of comparative modification.
Different focus.
All right. And C, employing techniques to identify weaknesses generally is too broad. That could cover many types of testing. Option D specifically describes the methodology of comparison testing on the dataset by modifying attributes to see the effect on outcomes.
So the key insight: comparison testing, by systematically changing data attributes, is a powerful experimental technique to understand exactly how different parts of your data influence your AI's behavior and outcomes.
A really useful tool for deep data understanding.
All right, back to data privacy, always critical. Which of the following would be most effective in ensuring adequate data privacy when developing an AI solution?
Most effective.
Okay.
Choices.
A. Use a supervised learning model. B. Implement data anonymization techniques. C. Ensure adequate data volume and variety. Or D. Use synthetic data instead of live data.
The most effective method listed here is B. Implement data anonymization techniques. This directly targets the protection of sensitive information within the data.
Anonymization. So this is about making the data, well, anonymous, right? Making it so you can't trace it back to a specific person, even if the data gets exposed somehow. How does that work in practice for building privacy-conscious AI?
Precisely. Data anonymization techniques are highly effective because their goal is to make it significantly harder, ideally, practically impossible,
Mm-hmm.
to link sensitive data back to an identifiable individual. This is a crucial risk reduction measure.
Even if there's a breach.
Exactly. Even if the anonymized data is compromised or accessed by unauthorized parties, the risk to individual privacy is dramatically reduced. There are various techniques like k-anonymity, ill-diversity, t-closeness, and differential privacy, each offering different levels of protection and utility trade-offs.
What do they do?
They might involve removing direct identifiers, names, exact addresses, generalizing data, replacing exact age with an age range, suppressing certain records, perturbing data slightly by adding noise, or aggregating data. By removing or obscuring that personally identifiable information, PII, you fundamentally reduce the re-identification risk.
You break the link to the individual.
Right. This proactive step is one of the best ways to ensure the privacy of the data used to develop and train AI. It's a cornerstone of privacy by design in AI systems.
Okay. And why are the other options considered less effective, even if they might have some privacy benefits?
Well, A, using a supervised learning model just describes the type of machine learning algorithm. It says nothing inherent about data privacy. You still need to protect the data used, regardless of the model type.
Irrelevant to privacy itself.
Mostly, yes.
Right.
C, ensuring adequate data volume and variety is vital for model accuracy, fairness, and avoiding statistical bias. But it doesn't directly address privacy. You could have a huge, varied dataset that's full of sensitive, identifiable information.
Volume doesn't equal privacy.
Correct. And D, using synthetic data can be very beneficial, especially when real sensitive data is scarce or too risky to use directly for training. It avoids using the original live data. However, it doesn't address the privacy concerns if actual sensitive data is still needed for validation, testing, or if the model interacts with real user data during deployment. Plus, creating high-quality, truly representative synthetic data is challenging. Anonymization directly tackles the privacy of the actual sensitive data you might be using.
So the key insight. Anonymization is a fundamental technique for privacy by design in AI. It directly protects individuals by making data non-identifiable, offering robust privacy assurance even in the face of potential breaches.
A critical tool in the privacy toolbox.
All right, Section 5, Information Quality Reporting and Managing Risk. Next, a practical question about data collection. Which of the following is fundamental for ensuring high data quality during interviews conducted to collect AI inventory information?
Getting good info for your AI inventory. Okay.
Options. A. Using a consistent set of questions. B. Encouraging open-ended discussions. C. Emphasizing technical details. Or D. Collecting info only from specific development teams.
The fundamental factor here for ensuring quality and consistency in an inventory is A. Using a consistent set of questions for interviewees.
Consistency. Why is that so crucial when you're just trying to figure out what AI systems an organization has?
Because an inventory needs structure and comparability. Using a consistent set of questions ensures that you collect uniform data across different interviews, different teams, different parts of the organization.
Everyone answers the same core questions.
Right. This uniformity is vital for establishing clear, comparable categories of AI technologies, their use cases, the data they use, their owners, their risk levels, etc., within the inventory. More importantly, it enables a much more effective and reliable analysis of the responses because you're comparing apples to apples.
You can aggregate the data meaningfully.
Exactly. Without that consistency, your inventory data would just be a fragmented collection of anecdotes and disparate facts. It would be nearly impossible to get a comprehensive, accurate, and comparable overview of the organization's entire AI landscape. Consistency provides the structure needed for high-quality, usable inventory data.
Okay. Why aren't the other methods as effective for ensuring high data quality, specifically for building an inventory?
Well, B, encouraging open-ended discussions is great for qualitative insights, uncovering unexpected uses, understanding context, very valuable for other purposes. But for building a structured inventory, it often lacks the consistency needed for a quantifiable and comparable data collection.
Can be too unstructured.
Right. C, emphasizing technological details is important for understanding the systems, but not all interviewees might have that deep technical knowledge. Focusing too much there could lead to inconsistent levels of detail, gaps, or even inaccurate information if people guess. Plus, an inventory needs more than just tech specs. It needs business context, ownership, risk info. And D, limiting information collection only to specific development teams, like central IT or data science teams, is a recipe for an incomplete inventory. AI is often developed or procured decentrally now. You could miss crucial AI use in marketing, HR, operations, resulting in a lower quality, inaccurate inventory.
You need a broad, consistent approach.
Exactly. Consistency is the bedrock for quality inventory data.
So, key insight. For a reliable AI inventory, asking everyone the same consistent questions is fundamental to ensure comparable, analyzable, and high-quality data across the organization.
Absolutely.
Okay, our 15th question looks at the benefits of good information. In what way does optimizing information improve the implementation of AI within organizations?
Why bother optimizing data?
Choices.
Hmm.
A, decreases reliance on large data storage. B, enhances speed and efficiency of processing. C, provides reliable information that supports decision-making. Or D, rectifies data inaccuracies and gaps.
The core benefit, the main reason you optimize information for AI, is C, it provides reliable information that supports decision-making.
Okay, optimizing information. That sounds like it could cover a lot. So what does it specifically mean for AI implementation, beyond just making things run faster or fixing errors?
You're right, it's broad, but at its heart, optimizing information for AI means ensuring the data and the insights derived from it are trustworthy, accurate, relevant, timely, complete, and fundamentally fit for the purpose they're being used for.
Fit for purpose.
Yes. And the primary purpose of most AI applications in an organization is to support or automate decision-making. So this optimized, reliable information becomes absolutely essential for making informed decisions throughout the entire AI project lifecycle.
From start to finish.
From the very beginning, strategic planning, choosing the right use cases through model design, training, validation, deployment, and crucially, ongoing operations and monitoring. The quality of the decisions made at every stage directly impacts the success, effectiveness, and trustworthiness of the AI implementation.
Garbage in, garbage out applies to decisions too.
Absolutely. If your AI runs on shaky, unreliable, or irrelevant data, or if the insights it generates aren't trustworthy, then the decisions derived from it, whether they're business strategy decisions, operational adjustments, customer interactions, or even safety-critical actions will be flawed. They could be ineffective, costly, or even harmful. High-quality, optimized information reduces uncertainty and boosts confidence in the AI's ability to deliver value.
It's the foundation for trustworthy AI-driven decisions.
Exactly, like building a house on solid ground versus swampland.
So the other options, while potentially positive outcomes, aren't the primary benefit driving the need for optimization.
Correct. A, decreasing reliance on large storage might happen in some cases through better data management, but it's often not the main goal. AI frequently benefits from large data sets. Cost savings are nice,
Sure.
but not the core purpose related to AI success. B, enhancing speed and efficiency is a definite advantage of optimized data pipelines. Things run faster. But speed doesn't guarantee good decisions if the underlying information is flawed. You can process bad data very quickly, but it still leads to bad outcomes.
Efficiency isn't effectiveness.
Right. And D, rectifying inaccuracies and gaps is a critical part of data optimization. It's a necessary step towards quality. But the broader purpose, the ultimate goal, is to ensure the information is trustworthy and directly supports better, more reliable, AI-driven decision-making, which encompasses more than just error correction. It includes relevance, timeliness, completeness, etc.
So the key insight. The fundamental value of optimizing information for AI lies in creating a reliable foundation for trustworthy, effective, and ultimately successful decision-making across the organization.
That's the bottom line.
Next, a question on communication. How to present findings.
Yeah.
Which of the following is the best way to integrate data visualizations into an AI audit report?
Making complex findings understandable.
Options. A, include them as appendices to the main report. B, exhibit them only in a presentation. C, use them as the basis of the entire report. Or D, include them as links within the text.
The best practice generally recommended is A, include them as appendices to the main report. This balances detail with readability.
Appendices. Why is that considered the best way? Doesn't it sort of hide the visuals away?
Not necessarily hide, but rather organize effectively. Including data visualizations, charts, graphs, diagrams as appendices significantly enhances the completeness and robustness of the audit report. They provide crucial supporting evidence and can make complex data patterns or findings much more accessible and understandable for stakeholders.
Easier to grasp than just tables of numbers.
Absolutely. Visuals allow for quicker digestion of complex information. Putting them in appendices serves a key purpose. It avoids interrupting the narrative flow of the main audit report.
Ah, so the main text tells the story.
Right. The main report lays out the findings, conclusions, recommendations, in a logical sequence. Readers who want the high-level story can follow that narrative smoothly. Those who need to see the underlying data, the granular details, or simply prefer visual summaries, can easily flip to the relevant appendix.
It caters to different reader needs.
Exactly. It provides multiple pathways to understanding the information effectively, maintaining both narrative coherence in the main body and providing comprehensive visual support in the appendices.
Okay. And why are the other methods less ideal for a formal audit report?
B, showing visuals only in a presentation is problematic. It restricts that valuable information only to those who attend. The report itself becomes incomplete, and people referring back to it later won't have access to the visuals.
Loses context.
Right. C, using visualizations as the sole basis of the entire report would severely limit the analytical depth, context, and detailed explanation the comprehensive audit report requires. Visuals are powerful summaries, but they typically supplement, not replace, in-depth textual analysis and interpretation.
Too superficial.
Could be. And D, including them as embedded links within the text, can be technically fragile links break. It can also make the report inaccessible to users without internet access or the right software, and it often disrupts the professional presentation and flow of a formal document. Appendices are self-contained and reliable.
So the key insight. Appendices provide the best balance for integrating visualizations into AI audit reports, offering detailed visual support without disrupting the main narrative, ensuring both clarity and completeness.
The standard best practice for good reason.
Now, here's a tough scenario. What is the best course of action for an organization when an AI-related risk exceeds acceptable levels, but it's considered unavoidable? Maybe the benefits are too high to abandon it entirely.
A common dilemma with cutting-edge tech.
Choices. A, modify the AI system even if it doesn't fully solve it. B, stop using the AI altogether, go back to manual. C, delegate AI system management to a third party. Or D, monitor the risk actively to manage potential escalations.
Given the scenario, the risk is high, but deemed unavoidable, the best course of action is typically D, monitor the risk actively to manage potential escalations.
Active monitoring. It sounds like you're accepting a certain level of known risk, but putting a really strong surveillance system in place, like a high-stakes tightrope walk where you can't eliminate the wind, but you have spotters and nets ready.
That's a very apt analogy. When an AI-related risk can't be fully eliminated or mitigated down to traditionally acceptable levels, perhaps due to the inherent uncertainty of the AI or the environment.
But the organization decides the potential benefits still outweigh this residual risk.
Exactly. In that situation, you can't just ignore it. Maintaining a proactive, rigorous risk monitoring strategy becomes absolutely crucial. This isn't passive monitoring, it's active surveillance.
What does that involve?
Continuously tracking key risk indicators, monitoring the AI's performance and outputs for any signs of trouble, watching the external environment for changes that might exacerbate the risk, and having predefined triggers and response plans for when things start to go sideways.
You're watching for early warnings of escalation.
Precisely. This active monitoring allows the organization to respond effectively and rapidly if the risk level changes, if negative consequences start to materialize, or if potential escalations begin. It ensures management stays aligned with the evolving risk landscape. It's about having robust contingency plans and constant vigilance rather than sticking your head in the sand.
Okay. And why aren't the other options considered the best in this specific, unavoidable high-risk situation?
Well, A, modifying the AI system is always something to consider. But the premise here is that the risk remains unavoidable even after modifications, or maybe modifications aren't feasible or cost-effective enough to bring the risk down sufficiently. So it might not be the final answer.
Right.
B, completely stopping the AI and reverting to manual operations might be necessary in extreme cases. But it means sacrificing all the benefits the AI provides: efficiency, capabilities, insights. It's often an overreaction if the risk, while high, can be actively managed.
Throwing the baby out with the bathwater.
Potentially. And C, delegating management to a third party might shift some operational tasks, but it doesn't eliminate the inherent risk or the organization's ultimate accountability. You'd still need significant oversight of the third party and the underlying risk. It doesn't make the unavoidable risk disappear.
So the key insight. When faced with unavoidable high AI risk that's deemed acceptable due to benefits, the best strategy isn't ignorance or delegation, but active, continuous monitoring and preparedness to manage escalations rapidly.
Vigilance becomes the primary control.
All right, moving into our final section, advanced audit perspectives and governance foundations. Question 18 looks at risks for the auditors themselves. Which of the following is the most significant risk when an internal systems auditor starts leveraging AI processes for their own evidence collection and audit work?
Auditors using AI.
Choices.
A. Using non-traditional data sources for testing. B. The audit team hosting its own historical data stores. C. Lack of audit staff experience with AI. Or D. Using synthetic data to train the audit AI models. This is a fascinating question about the changing role of audit. The most significant new risk introduced here is likely B. The audit team hosting its own historical data stores.
The audit team hosting data. That sounds unusual. Why is that such a big risk? What does it mean for the internal auditor's role?
It's unusual because, traditionally, internal auditors are reviewers, evaluators, assurance providers. They examine the organization's systems and data. They don't typically manage operational IT infrastructure or large data sets themselves.
They inspect the kitchen, they don't run it.
Exactly. But if the audit team starts using sophisticated AI tools to help them analyze trends, detect anomalies, collect evidence, those AI tools often need to be trained on historical data. And the audit team might need to create and maintain their own data store containing potentially sensitive historical company data to train and run these AI models.
Ah, so audit becomes a data custodian.
Precisely. And that's a fundamental shift. An auditor hasn't traditionally been responsible for implementing the security controls, the privacy protections, the data lifecycle management, the backup and recovery procedures for significant amounts of potentially sensitive organizational data.
It introduces a whole new set of responsibilities and liabilities.
Absolutely.
Yeah.
Primarily around data governance, data security, and privacy compliance, which they might not be equipped or resourced to handle adequately. It fundamentally changes their operational model and their own internal risk profile. It's a major shift from being purely an assurance function.
That's a really interesting point. And the other options, while perhaps risks, aren't as significant or transformative as this data hosting issue.
Correct. A, testing non-traditional data sources presents challenges. Sure, understanding the data, ensuring its reliability, but it's still within the auditor's traditional role of examination.
Yeah.
C, lack of audit staff experience with AI is a very real and significant challenge. Auditors need upskilling, but it's a competency risk that can be addressed through training. An improperly secured data store creates a more immediate and potentially severe operational and compliance risk.
Right.
And D, using synthetic data might actually be a mitigation strategy in some cases to avoid handling sensitive real data for training audit AI.
Right.
It's not inherently a significant risk in the same way as hosting large volumes of actual historical company data.
So the key insight. As auditors leverage AI, the most profound new risk isn't just using the tech, but potentially becoming custodians of large historical data sets, fundamentally shifting their role and introducing significant data governance responsibilities they haven't traditionally managed.
A major consideration for the future of audit.
Okay, next, back to a crucial application. AI in recruitment. An IS auditor is evaluating the design of an AI recruitment automation solution to mitigate potential biases. What critical steps should the auditor focus on to most effectively ensure equity?
Ensuring fairness in hiring AI.
Options. A. Conduct bias audits prior to deployment. B. Modify algorithms after deployment. C. Review code frequently for model drift. Or D. Concentrate only on the volume and variety of training data.
The most effective step, the one focused on prevention, is A. Conduct bias audits prior to deployment.
Pre-deployment bias audits. So essentially the message is, prevention is vastly better than trying to cure bias after the fact, especially in a sensitive area like hiring.
Absolutely. Conducting comprehensive bias audits before an AI recruitment system goes live is critical for ensuring equity. These systems deal with highly sensitive personal data, and their decisions have profound impacts on people's lives and opportunities.
The stakes are very high.
Extremely high. This proactive approach, testing the data for historical biases, examining the algorithm for discriminatory patterns, assessing the system's potential disparate impact on different demographic groups, helps identify, prevent, and mitigate biases before they can cause harm.
You catch it during design and testing.
Right. You ensure alignment with ethical standards and fair employment practices from the outset. It is far easier, far less costly, and far less damaging, reputationally and legally, to fix bias issues during the design phase than it is after a system has been deployed and potentially rejected qualified candidates unfairly or perpetuated historical inequities.
It's about building fairness in, not trying to bolt it on later or clean up a mess.
Exactly. Embed fairness from the ground up.
So why are the other options less effective for ensuring equity specifically?
B. Modifying algorithms after deployment is reactive. Biased decisions might have already occurred, causing harm. Plus, fundamental biases baked into the initial data or design might be hard to fix just by tweaking parameters later.
Closing the barn door after the horse is bolted?
Somewhat, yes. C, reviewing code for model drift is important for maintaining performance accuracy over time, as we discussed. But drift is primarily about performance degradation, not necessarily about addressing the foundational fairness and equity concerns present in the initial design or data.
Different focus.
In D, concentrating only on volume and variety of training data is insufficient. Data diversity is important, yes, but you can have a diverse data set that still reflects historical societal biases. For example, few women in historical leadership roles. And the algorithm itself might process that data in a way that creates disparate impact, even if the data looks diverse on the surface. You need a more holistic approach than just looking at data quantity and variety.
So the key insight for sensitive AI like recruitment, pre-deployment bias audits are absolutely paramount. It's the most effective way to build fairness and equity into the system from the start, preventing harm before it occurs.
Proactive prevention is the gold standard here.
Okay, question 20 revisits privacy adherence. Which of the following is a best practice to ensure AI solutions adhere to established privacy and data management policies?
Ensuring the AI plays by the privacy rules.
Choices. A. Establishing data preprocessing standards. B. Providing human oversight for outcomes. C. Ensuring privacy controls persist from source to solution. Or D. Applying data minimization practices.
The best practice, encompassing the end-to-end view, is C. Ensuring that privacy controls persist from the data source to the AI solution.
Control persistence. We touched on this earlier with the auditor's view. So it's like that data passport idea. Again, the privacy rules applied at the start need to travel with the data all the way into the AI.
Exactly. It's that concept of end-to-end data governance and privacy by design. The best practice is to ensure that any data protection and privacy controls apply to the data at its original source.
Like consent, purpose limitation.
Right. Consent, purpose limitation, access restrictions, required security levels, anonymization standards. All of those controls are effectively transferred, maintained, and enforced throughout the data's entire life cycle.
All the way through.
All the way from collection through transport, into storage, like a data lake, during pre-processing, and ultimately within the AI solution itself, both during training and when it's making predictions, inference. This guarantees the AI solution consistently operates within the established privacy and data management policies.
It prevents gaps where protections might fall away.
Precisely. It's not enough to have controls only at the source or only within the AI application. They must persist and be effective across the entire ecosystem the data touches.
Okay. And the other options, well, good practices aren't as comprehensive in ensuring this persistence.
Correct. A, establishing pre-processing standards is mainly about data quality and suitability for the model. It doesn't inherently guarantee the persistence of privacy controls throughout the lifecycle.
Okay.
B, human oversight for outcomes is critical for quality, fairness, and catching errors. But it's focused on the output, not directly ensuring the underlying privacy rules were followed for the data input and its journey.
Different stage.
And D, applying data minimization using only necessary data is an excellent and fundamental privacy principle. Absolutely do it. But option C is broader. It implies that minimization, along with all other applicable privacy controls, must persist and be enforced end-to-end. So C encompasses D and more, ensuring the entire suite of controls follows the data.
So the key insight. Ensuring AI adheres to privacy policies isn't just about setting rules initially, but critically about ensuring those rules and controls persist and are enforced consistently throughout the data's entire journey within the AI ecosystem.
End-to-end persistence is the goal.
Question 21 looks at the role of academia. How would academic research best inform best practices for AI solutions in industry?
Bridging the gap between research and practice.
Options. A. Establishing AI development standards directly. B. Enabling regulatory frameworks directly. C. Dictating specific AI algorithms to use. Or D. Providing industry insights.
The way academic research typically best informs best practices is D, by providing industry insights. It plays a foundational informing role rather than a dictatorial one.
Providing insights. So academia explores the frontiers, generates knowledge, and then industry translates that into practical guidelines. How does that work?
That's generally how it functions best. Academic research plays a crucial role by offering deep, often theoretical or experimental insights. They might explore fundamental limitations of current AI approaches, propose novel methods for things like bias detection or mitigation, develop new optimization techniques, identify emerging ethical considerations, or test the boundaries of AI capabilities in controlled settings.
Pushing the envelope.
Exactly. These findings, published in papers, presented at conferences, then provide the intellectual groundwork and the evidence base that industry practitioners, standards bodies, and regulators can draw upon. People in specific sectors, finance, healthcare, retail, energy, can take these academic insights and integrate them into their operational guidelines, risk assessments, and best practice documents, adapting the theoretical knowledge to their practical context.
So academia provides the raw material for best practices.
Often, yes, it provides foundational understanding, new ideas, and evidence that helps shape what best practice looks like.
Why aren't the other options considered the best fit for academic research's primary role?
Well, A, establishing development standards is usually a collaborative effort involving industry bodies, practitioners, regulators, and academic input. Academia informs standards, but rarely establishes them unilaterally for industry.
More collaborative.
Right. B, enabling regulatory frameworks is similar. Academic research heavily influences policy debates and informs regulators about capabilities and risks. But the actual enabling and enforcement of regulations falls to governmental and oversight bodies.
Different roles.
And C, dictating algorithms to use is generally not the role of academic research in a commercial context. Academia develops and evaluates algorithms, proposes new ones, but the choice of which algorithm to use in a specific product or service is typically driven by business needs, performance requirements, cost, data availability, and other practical factors, although academic findings certainly influence those choices.
So the key insight. Academic research best informs AI best practices by providing the foundational insights, evidence, and exploration of possibilities that industry and regulators can then use to build practical standards, guidelines, and frameworks.
An essential part of the ecosystem, providing that deeper understanding.
Okay, question 22 gets back to audit techniques for bias. Which sampling method is best suited for an auditor examining a large dataset in an AI system, specifically to ensure bias concerns have been addressed?
Sampling to find bias in big data. Tricky.
Options. A. Judgment-based sampling. B. Random sampling. C. Demographic stratified sampling. Or D. Processing metric-based sampling.
For the specific goal of targeting potential bias concerns in a large data set, the best suited method listed is A. Judgment-based sampling.
Judgment-based sampling again. We talked about needing domain expertise for this. Why is it particularly good for finding bias compared to, say, random sampling?
Because bias isn't always evenly distributed throughout a data set. It might be concentrated in specific subgroups or related to specific features or historical periods. Pure random sampling, while good for getting a generally representative picture of the whole dataset, might easily miss these specific pockets of bias, especially if they affect a relatively small proportion of the data.
You might just randomly miss the problem areas.
Yes, exactly. Judgment-based sampling, however, allows the auditor to leverage their expertise, their understanding of the domain, relevant regulations, known societal biases, and the specifics of the AI application to deliberately select samples that are most likely to reveal potential bias issues.
You target the high-risk areas.
Right. You might specifically sample data points related to protected characteristics like race, gender, age, or focus on edge cases, or examine decisions where the AI showed low confidence, or investigate data from periods known to have historical bias. This targeted approach significantly increases the likelihood of detecting subtle or embedded biases that a purely random or generalized method might overlook in a massive data set.
It's a more focused investigation.
Precisely.
So why aren't the other sampling methods the best for the specific goal of ensuring bias concerns are addressed?
B, random sampling, as we said, is good for overall representativeness, but poor at targeting specific, potentially rare bias issues.
Might miss the needle in the haystack.
Could do. C, demographic stratified sampling is useful. You divide the population into demographic groups, strata, and sample from each. This helps ensure representation and allows comparison between groups. But it's limited to the predefined demographic strata you choose and might miss other types of bias not linked to those specific demographics. Judgment sampling can be more flexible.
Okay.
And D, processing metric-based sampling, focuses on technical aspects. Sampling data points that took longer to process or resulted in errors or had certain computational characteristics. Useful for performance or system issues, perhaps, but it completely overlooks the fundamental need to address underlying data bias related to fairness and equity, which are often qualitative and contextual concerns, not just processing metrics.
So the key insight. When auditing large AI datasets specifically for bias, judgment-based sampling is often the most effective method because it allows the auditor to use their expertise to target high-risk areas and increase the chances of detecting specific, potentially hidden biases that random methods might miss.
The right tool for that specific job.
All right, final section. Adapting to change, consequences, and governance initiation. Question 23 looks at why we monitor AI predictions. Which of the following describes the primary purpose of observing the predictions an AI solution makes over time?
Why keep watching the AI's output?
Choices. A, to continuously enhance model intricacy. B, to develop processes to retrain if necessary. C, to ensure new data inputs are added regularly. Or D, to handle changes in data and models effectively.
The primary purpose here is D, to handle changes in data and models effectively. AI systems exist in a dynamic world.
Handling changes. So it's about keeping the AI relevant and accurate as the world, the data, or even the model itself changes.
Exactly. Observing the predictions an AI solution makes on an ongoing basis is crucial because it provides the feedback loop needed to manage the inevitable changes that occur. Data drifts, as we discussed. The underlying patterns in the real world might change. Concept drift. Business requirements might shift. Even the model itself might degrade subtly over time.
Things aren't static.
Not at all. This continuous observation, looking at accuracy, prediction distributions, confidence scores, identifying anomalies, ensures that the organization can detect when the AI system is becoming misaligned with reality or business needs. It allows them to adapt.
How?
By triggering actions like investigating the cause of the change, updating the data pre-processing, retraining the model with new data, fine-tuning parameters, or even deciding to retire or replace the model if it's no longer effective. Without this ongoing observation and feedback, an AI model can quickly become stale, inaccurate, or even harmful, leading to deteriorating performance and bad decisions.
It's about maintaining the health and relevance of the AI in a dynamic environment.
Precisely.
So the other options are consequences or supporting activities, not the primary purpose of the observation itself.
That's right. Enhancing model intricacy just for the sake of it is often counterproductive. Observation might tell you the model needs simplifying or changing, not necessarily making it more intricate. Overly intricate models can be inefficient and prone to overfitting. B, observation certainly informs the need for retraining. It provides the signal that retraining might be necessary. But developing the retraining process is a response to managing changes identified through observation, not the primary purpose of the observation itself.
Observation triggers the process.
Yes. And C, ensuring new data inputs are added regularly is part of data pipeline management. Observation focuses on how the model is performing with that data and adapting to changes in that data or the world, not just the logistics of adding more data.
So the key insight: the primary reason for continuously observing AI predictions is to effectively manage the inevitable changes in data, models, and the real world, ensuring the AI remains accurate, relevant, and reliable over time.
It's about adaptive management.
Next up, a question about what happens when things go wrong in testing. What is a potential consequence if a program designed to remove noise from data during the integration testing of an AI system is found to be flawed?
Flawed noise removal.
Well,
What could happen?
choices. A, output time might significantly increase. B, sensitive data might be exposed. C, the AI solution may produce harmful or biased outputs. Or D, operating costs might increase.
The most critical potential consequence here, directly linked to the AI's function, is C. The AI solution may produce harmful or biased outputs. This really highlights the direct link between data quality and AI integrity.
Harmful or biased outputs. Wow. So a flaw in what seems like a small technical step, cleaning up noise, can have really big negative implications down the line.
It absolutely can. Integration testing is where you bring different components of the AI system together to see if they work correctly as a whole. Data preprocessing, including noise removal, is a fundamental early step in the AI pipeline.
Getting the data ready for the model.
Right. Noise can be irrelevant information, errors, outliers, or even potentially misleading data points. If the function designed to identify and remove this noise is defective, maybe it removes too much valid information or fails to remove actual noise, or even introduces new errors.
The data going into the model is compromised.
Exactly. The AI model will then be trained or make predictions based on this flawed, noisy, or incomplete data. This directly leads to the AI solution producing outputs that are inaccurate, unreliable, potentially harmful if it's a safety-critical system, or even biased if the noise removal process disproportionately affects certain groups or features.
Garbage in, garbage out, amplified.
Precisely.
Uh-huh.
A seemingly small flaw in this foundational data preparation step can have cascading and very significant negative effects on the AI's reliability, fairness, and trustworthiness in its real-world applications.
Okay. And why are the other consequences listed less direct or less significant in this context?
A, the time to produce output, inference speed, is generally more dependent on model complexity and hardware resources, not primarily affected by the amount of noise in the data, although very messy data might slow preprocessing slightly. B, exposure of sensitive data is a security privacy issue usually related to access controls or data handling procedures. While noisy data might coincidentally contain sensitive info that should have been removed for other reasons, a flaw in a noise cleansing program isn't directly about unauthorized access.
Different category of problem.
Right. And D, operating costs are typically driven by computational resource usage, maintenance, etc. A malfunction in a data filtering component is more likely to impact output quality than significantly drive up sustained operational expenditure unless it causes massive processing errors, which is less direct.
So, the key insight. Flaws in fundamental data preprocessing steps like noise removal can directly corrupt the data fed to AI models, leading to potentially harmful, biased, and unreliable outputs, underlining the critical importance of data quality.
Data quality is paramount.
And finally, our last question. We end by looking at how to set up effective AI governance from the start. Which of the following is the first step an enterprise should take?
Laying the foundation for responsible AI.
Options. A. Start developing specific AI technologies. B. Define roles and responsibilities related to AI solutions. C. Create metrics for potential AI applications. Or D. Deploy AI solutions across the enterprise.
The absolutely essential first step for establishing effective AI governance is B. Define roles and responsibilities related to AI solutions. This is the cornerstone.
Roles and responsibilities first. So it's like that construction project analogy again. You need to know who the architect, engineer, and site manager are before you even order the materials or start digging the foundation.
That's a perfect way to think about it. Establishing clear roles and responsibilities for AI, alongside setting the organization's overall strategic direction and ethical principles for AI use, forms the fundamental building blocks. Without this clarity, everything that follows will be built on shaky ground.
Chaos ensues.
Potentially, yes. This essential first step provides the necessary framework for accountability, oversight, and decision-making. You need to answer, who is accountable for the ethical review of AI systems? Who owns data quality for AI? Who is responsible for model validation and risk assessment? Who approves deployment? Who monitors ongoing performance and compliance?
Knowing who owns what and who does what.
Exactly. Without a clear understanding of these accountabilities, any efforts to develop metrics, initiate projects, or deploy solutions will lack structure, oversight, and clear direction. It leads to confusion, duplicated effort, gaps in responsibility, and increased risk.
You need the organizational structure first.
Yes, the governance structure. Clarity on roles and responsibilities is paramount before you dive into the technical or operational aspects.
So, why are the other options definitely not the first step?
A, initiating development of specific AI tech is putting the cart before the horse. You shouldn't start building until you have a strategy, ethical guidelines, and clear roles defined. Development without governance is risky. C, creating metrics is crucial for measuring success and risk later on. But metrics need context. They need to align with strategic priorities and responsibilities defined by the governance structure. You need to know what you're measuring against and who is accountable for those metrics.
Metrics need a framework.
Yes. And D, deploying AI solutions across the enterprise is obviously a very late-stage activity. Deploying AI without a robust governance structure, clear accountability, and proper risk management in place is a recipe for potential disaster, compliance failures, ethical breaches, operational problems, reputational damage.
You need the guardrails before you let the car on the road.
An excellent summary. Governance comes first.
So the key insight, the absolute first foundational step for effective AI governance is establishing clear roles and responsibilities. This provides the essential structure, accountability, and direction needed before embarking on AI development, metrics creation, or deployment.
Get the foundations right, and the rest follows more smoothly.
And that brings us to the end of, wow, a really illuminating deep dive into the world of AI auditing and governance. We've journeyed through some complex concepts
We really have. From the subtle but critical power of those hyperparameters.
to the absolute necessity of proactive ethical assessments and bias audits before things go wrong.
The importance of privacy controls that persist end to end.
And even the need for auditors to have deep domain knowledge. It's quite a landscape.
It really is. And if we try to connect this all back to the bigger picture, what these questions collectively show, I think, is that getting AI right isn't just a technical coding challenge.
No, definitely not.
It's a comprehensive, multifaceted endeavor. It requires meticulous attention to data quality, data governance, deep thought about ethical implications, robust risk management processes tailored to AI's uniqueness, and strong, clear governance frameworks.
Understanding all these interconnected pieces is becoming paramount for anyone working with or impacted by AI.
Absolutely. It's about building trust, ensuring responsibility, and ultimately making sure this powerful technology serves us well.
So what does all this mean for you, listening in? Hopefully, this deep dive has given you a shortcut to being better informed, arming you with some crucial insights into what goes into the responsible development and deployment of AI systems.
Yeah, the kinds of questions organizations should be asking themselves.
Exactly. And as AI continues its rapid evolution, think about how these principles we've discussed, transparency, continuous monitoring, proactive risk mitigation, structured accountability, fairness by design, how they'll become even more vital.
They really are the bedrock for ensuring AI serves humanity ethically and effectively.
This isn't just about passing some hypothetical audit exam. It's about understanding the mechanics of building a better, more trustworthy future with AI.
Well put. And there's always more to learn, of course. We hope this conversation sparks your curiosity to delve deeper into these critical areas. Maybe even apply some of this thinking when you encounter AI systems in your own life.
Great point. Thank you for joining us on this deep dive. Until next time, keep learning and stay curious.